Graphs are a visual means for communicating relationships between variables. In this course, we are going to use graphs to validate the form of some of the equations that will be used. So, in a real sense, some of what we do with the data is a little different than what we do in a math class. For example, sometimes, from a graphing point of view, it might be necessary to give up the traditional idea of independent variable on the horizontal axis and dependent variable on the vertical axis. Instead, what can be done is to place the variables on that axis that makes sense for the equation we want to validate. In an earlier video, I detailed the steps for creating a graph. In this one, I will be doing those steps, but not explicitly saying what needs to be done. If you need more details, I'll refer you back to that earlier video. Sometimes the data is an obvious linear relationship, but in some cases that is not going to be the case. One should not assume that the data will be fit to a straight line. Instead, be prepared to try different fits to the data to find the best one. To experiment, click on the plus sign to the right of the graph, go down to Trend Line, and hover there to get the option arrow that will let you then choose more options. Initially, a linear fit will be attempted. If the data is not linear, do not choose that option. In some cases, a polynomial fit of different powers of the horizontal variable might be the better option. This will depend on the physics equation we are wanting to validate. In this example, a linear fit is sufficient. But we don't stop here. If we were doing this by hand, we would extend the line to intercept the vertical axis. That is because if the relationship is linear, we would expect it to be described by the equation for a straight line, y is equal to mx plus b, where the m before the x variable is the slope and the b term is the y-intercept. We will be recreating this generic mathematical equation into a specific physics equation for comparison purposes, so units are just as important as numbers that show up in this equation. To get the data to pass through the y-axis, the y-intercept, go to the bottom of the trend line options window. One item listed there is called forecast, below which is a forward box and a backward box. The backward box is useful here because it lets us forecast back toward the y-axis. To get there, we use our lowest x variable and put that in the box. When you click outside the box, a line is extended beyond the data set toward the y-axis. Sometimes this can rescale either the horizontal or vertical axis. To fix this, click on the axis set that needs to be fixed, and a box should show up around the numbers of that axis. Click on the plus sign again, and this time choose Axes and more options. There should be a Bounds section that opens up, and you will see the minimum and maximum values in boxes. Here is where you can manually set the maximum and minimum bounds on that axis in an attempt to make the data span the full graph. If the other axis needs to be fixed, click on it, put the appropriate values in the maximum and minimum boxes for that axis. When complete, one has a complete, correctly done graph. This can now be inserted in the lab write-up.